If it's quadratic, we have to get it equal to 0, and then we need to factor. So this would be a box method problem. So if we multiply 2 times negative 12, so multiply to negative 24, and add to positive 5, what would that be? Okay, so then we factor. So we have 2x minus 3 and x plus 4. All right. Then what? What we decided yesterday is we can't just set each of those greater than 0. So we had to do two things. We had to find out what made each parenthesis equal 0, and then we either looked at a graph or plugged in those test points to decide. So if I want 2x minus 3 to equal 0, that would be 3 over 2. And if x plus 4 equals 0, that would be a negative 4. When you put them on your number line, the smaller one has to go on the left. And then I think a couple of you like to plug in points. The majority of you who are using the graph. I'll go ahead and talk about both ways, just so everybody's seeing however they want to think about it. When you do test points, you have to pick a number for each interval. So smaller than negative 4, right? In between negative 4 and 3 halves, and bigger than 3 halves. Or you choose. If I plug these in, if I put in negative 5, all I care about is the positive or the negative. So that would be a negative times a negative, which is positive. If I put in a 0, I get a negative times a positive, which is negative. If I put in a 2, we get a positive times a positive, which is positive. To decide what part I need, we look right here. We wanted greater than or equal to 0. Greater than means positive or negative? Positives. So I can see this whole section of the graph is positive, and this section is positive. Equal to means brackets. So this first section is going forever in the negative direction, so that's coming from negative infinity. Infinity's always get a parenthesis. Stops at negative 4, which gets a bracket. Union, bracket, 3 halves to positive infinity. Let's talk real quick if you were using the graph. So you can plot just this first thing once it's equal to 0. So that was 2x squared plus 5x minus 12. So I can see first it's above, so that's positive, then it's below, which is negative, and then it's above, which is positive. So we still get positive, negative, positive. Does everybody understand how to get those signs? Doesn't matter which way you do it. Can everybody get them somehow? All right. Why don't you guys try the next one on your own? And you got 3x plus 1, x minus 4. Less than 0 tells us we are going to want when this graph is negative. If you set it equal to 0, that one's a negative 1/3. This one was a positive 4. There's no equal to, so we're talking parentheses. Whether you plugged in test points or looked at a graph, this part was above the axis or positive. Then it went below or negative, and then it came back up, which was positive. We said we wanted the negatives, no equal to, so it's just this section. So negative 1/3 to 4. All right. So what we're going to look at next is maybe something a little less predictable than a quadratic, because if you haven't noticed, all these kind of are following the same pattern, positive, negative, positive. And it's not always the case that it works out like that. So I want to take a rational inequality here. So this is the final type of problem we have to look at. Okay. If this were an equation, it wouldn't be any big deal to solve, because you would just multiply both sides by x plus 4 and get 5 equals x plus 4, and that's easy to solve, right? But we have a problem. I don't know what x is. Do you know if x plus 4 is positive or negative? No. Why does that matter? Yeah, if you multiply by a negative, it flips the inequality. So since I don't know if this is positive or negative, I don't know if I would flip my inequality or not, so I can't multiply it over. So our strategy instead, with quadratics, we always wanted a 0 over there, and then we factored. What we're going to do is get it equal to 0 and get a single fraction on the other side. So I'm going to start out by subtracting over my 1. So I've got my 0. I have to combine these into a single fraction. This is like a 1 over 1. What do you need to add or subtract fractions? Same denominator. So I need to turn this into x plus 4 on the bottom. And whatever you do to the bottom, you have to do to the top as well. So I'm going to multiply by x plus 4 on top and bottom. Okay, so to put these together, I have to distribute this negative. So 5 and negative 4 gives me a 1 minus x over x plus 4, greater than or equal to 0. Okay, when we got down to 2 parentheses multiplied, we set each one to 0. Once we get our single fraction, we are going to set both the top and the bottom equal to 0. So we get a negative 4 and a positive 1. I added my x to the other side. If you subtracted your 1, then you would have to divide by an equal on both sides. Okay, next step is kind of like what we were doing. Either pick a test point or put it in the calculator. If I picked points, let's be like a negative 5, a 0, and a 2, and you're just going to plug them into this fraction, and all we care about is if it's positive or negative. If I put it in a negative 5, 1 minus negative 5 is positive. Negative 5 plus 4 is negative, and if you take a positive divided by a negative, you get a negative. You put in a 0. 1 minus 0 is positive. 0 plus 4 is positive. Positive divided by positive, still positive. Put in a 2. 1 minus 2 is negative. 2 plus 4 is positive. Negative divided by a positive is negative. Let's look at that on the graph. Maybe. Okay, so you go to your y equals. When you put in this fraction, you have to do parentheses. So on the top I have parentheses 1 minus x. divided by, let's see, x plus 4. So, before the negative 4, that's this section of my graph. Can we all agree that is below the axis? So that is negative. After negative 4, my graph jumps up here. That's above the axis, so that is positive. After 1, it comes back down below, so it is negative. Alright, can you guys, does everybody understand how to get the positive or negative, either by plugging in numbers or by the graph? Which ones did I want? Greater than 0 means positive. Okay. We have equal to, which means brackets. However, if I do this, my answer is not correct. Does anyone know why? So? If you put in a negative 4, what do you get on the bottom of your fraction? 0. Can we have 0 on the bottom of the fraction? No. So if it's a fraction, it doesn't matter if I have an equal to or not, the denominator will always get a parenthesis because you can't make the bottom equal to a 0. So my answer here is parenthesis, negative 4 comma 1. The 1 gets a bracket because it's okay for the top of the fraction. A little more fuzzy than the quadratic ones, I'm guessing. Can we do some more of them? Let's do this one next. So we can't multiply by the bottom because the bottom has an x. And I wouldn't know if that flipped my sign or not. So instead, we have to bring over the 4. So I get 3x plus 1 over 2x minus 3 minus my 4. That's like a 4 over 1. So if we need a common denominator, we're going to have to multiply it by 2x minus 3 on top and bottom. So if I distribute my 4, I get 12. Now what? Distribute this negative. So positive 3x and negative 8x is negative 5x. 1 plus 12 is 13. So now we have to set the top and the bottom equal to 0. So I get 13 fifths and 3 halves. Which one is smaller? 3 halves. That's like a 1.5. 13 fifths is 2.6. Okay. So now you can use the calculator or plugging in points. If I wanted to look at the calculator, go to your y equals. Make sure you do parentheses around the top and bottom. what would my signs be? Starts out below the axis, which is negative, then above, which is positive, and then below, which is negative. Yeah. Which answer should I want, positives or negatives? Less than 0 is negative. There's no equal to, so I don't even have to worry. Everything's parentheses here. So I have both ends. So the first end is coming from negative infinity, stopping at 3/2. Union, the second piece is 13/5 to positive infinity. You guys want to try to set up one on your own? Top and bottom equal to 0. Which one's smaller? If you pick test points on this one, you would have to use some decimals, which is no big deal. But if you were trying to do that, you could start with maybe a -2 here. If you look at the decimal approximations, -21/13 is like a -1.6, and this is -1.3, so you might put in like a -1.5 if you were wanting to plug in points, and then -0. Or if we look at our graph, we can see this one is negative, positive, negative. Just fair warning, these rational ones don't have to follow any sort of pattern. So it's not always going to be negative, positive, negative. It is possible to get 2 positives in a row or 2 negatives in a row. So just make sure you're checking the graph every time, not just assuming that it's going to look the same as the last one you did. Which answer should we want? Negatives. Again, I didn't have an equal to on this one. So it would be a negative infinity to -21/13. Union -4/3 to infinity. If I had put an equal to on this, what would change? this had been equal to, what would have gotten a bracket? The negative 21 over 13 would get a bracket. Would the negative 4/3? No, because it made the bottom 0. You can't ever get 0 on the bottom. Questions for me? So that's all I have for you. Yesterday I gave you up through 34. So here are the remaining problems.